Have you ever wondered what space sounds like? Now that's a question that might lead to some furrowed brows. The common perception is that space is silent, a vast, endless void of nothingness. But that's not entirely accurate. It's true that sound, as we understand it on Earth, doesn't exist in space. Sound waves, which rely on air or another medium to travel, can't traverse the vacuum of space. But that doesn't mean space is completely silent. Let's dive a little deeper. In the cosmos, sound takes on a different form. It's not the kind of sound you can hear with your ears, but it's there nonetheless. These sounds are the electromagnetic vibrations that pulsate in similar wavelengths as the sound waves we're familiar with. And guess what? We've found a way to listen to them. Enter sonification, a technique that translates data into sound. This is how we listen to the universe. NASA, the world-renowned space agency, uses sonification to translate the vibrational data gathered from space into sounds we can hear. And it's not just random noise. Each sound corresponds to a specific piece of data, creating a symphony of cosmic information. Sonification is a bit like learning a new language, a language spoken by the universe itself. With the help of technology, we translate the silent whispers of the cosmos into something audible, something comprehensible. It's a beautiful harmony of science, technology, and our innate curiosity about the world beyond our own. So the next time someone tells you that space is silent, you can confidently correct them. Space is not a silent void. It's a concert hall filled with cosmic symphonies waiting to be heard. And thanks to the magic of sonification, we can tune into this celestial performance. So, space is not silent after all, it sings a song that we can hear through sonification. But how exactly do we make the stars sing to us? Imagine standing on a distant planet gazing up at the same stars we see from our home on Earth. But instead of seeing with our eyes, we're listening with our ears. This is the magic of sonification. Sonification is the process of translating data, like light or radio waves, into sound that we can hear. It's a bit like the way a radio turns invisible waves into your favorite song, but instead of music, we're tuning into the universe itself. First, we need to gather the data. This is where NASA's fleet of telescopes comes in. These floating eyes in the sky capture all sorts of data from across the cosmos, from the scorching light of distant stars to the faint whisper of radio waves from galaxies billions of light years away. Once we've got our data, it's time to turn it into sound. We use software that assigns different pitches and volumes to different data values. For example, a bright star might be a high, loud note, while a distant galaxy might be a low, quiet hum. There's no one-size-fits-all approach to sonification. Different teams and different projects will use different techniques depending on what they're trying to achieve. Sometimes we might want to create a beautiful symphony of the stars. Other times we might want to use sound to help us understand complex data patterns that our eyes might miss. But the end result is always the same. We take the silent, invisible data from the farthest reaches of the universe and turn it into something our human senses can understand. We turn the invisible into the audible, the distant into the near, the unknown into the known. And the best part? You don't need to be a NASA scientist to listen in. With the right tools and a little bit of patience, anyone can tune into the music of the cosmos. It's through this process that we can listen to the music of the cosmos. What does the universe sound like then? You might be surprised to learn that the cosmos is not a silent void, but a symphony of celestial music. Let's consider the different sounds produced by diverse space phenomena. Each celestial body, each event in the cosmos emits a unique sound signature that we can capture and translate through sonification. These sound signatures are as distinct as the entities they represent. Take planets, for instance. They emit radio waves captured by our satellites and transformed into sound. Mars, with its thin atmosphere and violent dust storms, produces a low, rumbling drone like a distant thunderstorm. Jupiter, the gas giant, sings with a chorus of high-pitched whistles and deep resonating hums, reflecting its powerful magnetic field and raging storms. Next we have stars. Our own sun, a medium-sized yellow star, resonates with a steady pulsating rhythm akin to a heartbeat. It's the sound of nuclear fusion, the process that fuels stars, transforming hydrogen into helium. In contrast, a neutron star, the dense remains of a supernova explosion, emits a rapid, high-pitched, pulsing sound like a galactic lighthouse. Lastly, let's not forget about galaxies. These vast cosmic cities, home to billions of stars, generate a gentle, harmonic hum. It's a complex symphony, composed of countless individual notes from its resident stars, planets, and other celestial bodies. The Milky Way, our home galaxy, creates a soothing, low-frequency melody a testament to its grand scale and dynamic nature. Through the art of sonification, we've given voice to these silent celestial bodies, letting them sing their unique songs. Each sound tells a story, reveals a secret about the body that emits it. It's a fascinating way to explore the cosmos, to listen to the music of the spheres. From the gentle hum of a distant galaxy to the eerie whistles of a hidden planet, the universe is filled with a symphony of sounds. Why does listening to the universe matter? Think about the vast cosmos filled with galaxies, stars, and planets, all sending out waves of information in the form of light. For many of us, we perceive this information through our eyes. But what about those who can't rely on sight to explore the universe? Here's where the beauty of sonifications comes into play. Sonifications, the process of translating data into sound, are a powerful tool for people who are blind or have low vision. It's like using a new sense to explore the universe. The pitch, volume, and rhythm of the sounds help to paint a picture of the cosmos in the mind's eye. A high pitch might represent a bright star, while a low rumble could indicate a dark nebula. The rhythm and tempo might help describe the movement of celestial bodies. This isn't just about accessibility though. Sonifications offer a unique perspective to everyone, regardless of visual ability. They provide a new way to experience and understand the cosmos. We're all familiar with the saying, "A picture is worth 1,000 words," but in the case of sonifications, we might say, "A sound is worth 1,000 pictures." Listening to the universe introduces us to patterns and relationships that we might miss when we're solely relying on our eyes. And it's not just about the data. These are not arbitrary sounds. Each one is meticulously crafted, turning raw data into a symphony of the stars. The result is a deeply engaging and often emotional experience. It's almost like listening to a piece of music composed by the universe itself. Remember, space is not just a visual experience, it's an auditory one as well. The universe is speaking to us in a language of light and sound, and sonifications are our translator. They're our ticket to a concert where the performers are stars, galaxies, and nebulae, playing a symphony billions of years in the making. Sonification allows us to listen to the universe, opening up new ways of understanding and appreciating the beauty of the cosmos. What does the future hold for sonification? This question, my friends, is as vast as the cosmos itself. As we stand on the precipice of an era defined by innovation and discovery, the potential for sonification seems limitless. Much like the universe, it helps us understand. Sonification's applications extend far beyond the realm of space exploration. Imagine, for instance, the field of medicine. Sonification could translate complex medical data into sound, allowing doctors to listen to a patient's health. It could help identify anomalies in heartbeat patterns or the subtle changes in brain activity that might signal the onset of a condition. In the realm of environmental science, sonification could allow us to hear the health of our planet. Changes in climate patterns, the ebb and flow of tides, or even the subtle shifts in tectonic plates could be converted into sound. This could lead to more accurate predictions of natural disasters, helping us to mitigate their impact. And let's not forget the potential for everyday people to get involved in this field. With the democratization of technology, more and more people have access to the tools necessary to experiment with sonification. This could lead to a surge in creativity and innovation, with individuals from all walks of life contributing to our understanding of the universe. The future of sonification, then, is a symphony waiting to be composed. It's a melody that holds the potential to change the way we perceive the world and the universe beyond. As we continue to refine this technique, to push the boundaries of what is possible, we are certain to uncover new layers of understanding. So we find ourselves at the threshold of an exciting new chapter in our quest to understand the cosmos. As we continue to listen to the universe, who knows what secrets the cosmos will reveal to us next?